Hey guys, it's James, and after doing multiple stringing tests, actually there's more. There's even more. And even more than that. I've come to the conclusion that it is impossible or nearly impossible to get rid of all the stringing like this. If you plan on doing the stringing calibration, make sure you do the E-step calibration and the PID tuning first. I have a couple of videos that I'm going to post up here. You can watch that playlist. I'm using Cura 4.6.1, and I got to tell you that the default settings for Cura are pretty good. So you want to upgrade to the 4.6.1. I would say that these cylinder tests is not that hard. This is a 0.6 millimeter in diameter, and they're about 34 millimeters apart. Getting rid of stringing on this is not that difficult. Now, getting rid of the stringing on this in a cone shape, it is going to get more difficult and nearly impossible to get rid of all the stringing. Let me show you another one. Like this. It's very difficult to get rid of all the stringing, if not nearly impossible. So I'm going to show you a couple of the main things you should be taking a look at while doing these profile changes. And if you go to my Thingiverse account, you can actually download all these calibration tests. I put a designation on them like a CB, CC, CA for a lot of them, so you don't have to do all of the work. This way you can just go to your text editor and then you can just put a designation and just put the settings inside. The only way to really do the calibration is to make one change at a time to the profiles, and that's the only way you can actually compare the models and see if it's working or not. That's why I put in the effort of just adding the designation on the bottom of the plate so you guys don't have to do it. A lot of the calibration process is just a lot of tedious work. If you find videos like this helpful, and if you want to help me out, there is a little button right here. It says tip the designer. If you want to tip me, you can do that. It will help me out in the purchasing of more filament to do these calibration tests. And even if you don't decide to tip, I would appreciate it if you can actually click on the subscribe button, click on the like, leave a comment, and share this video. If you take a look right here, I'm using a 0.8 millimeter nozzle with a 0.64 millimeter resolution on my CR10S PRO. And if I go right here to my ENDER 3, I am using a 0.4 millimeter nozzle with a 0.2 millimeter resolution. And once I have it dialed in even more, I will be posting my own profile here on this things file right here. Just look for it. This is going to come later on. Let me just give you a close-up. If you take a look, this was printed on the ENDER 3 with a 0.4 millimeter nozzle. The diameter of this top part is 6 millimeters. It's about 45 millimeters from top to bottom and 34 millimeters from here edge to edge. There is hardly any stringing. There is a little bit of like a blobbing, a little bit of zits where the seam is. There is a stray filament that got on there, but as you can see, this is a pretty good print, and getting this quality print is not that hard using a 0.4 millimeter nozzle. The difficulty is doing it with a 0.8 millimeter nozzle. This is done with my CR10S PRO with a 0.8 millimeter nozzle, and there is some hairline stringing right here. This amount of stringing, you can really just get rid of it by using a heat gun. These were not really hard to do. These were pretty much easy. The difficulty is when you're doing these cones, not even the cones, I would say as the diameter gets smaller, it's more and more difficult to get rid of these strings. And again, this is the 0.4 millimeter nozzle, and you can see there are some strings here, but if you just pull it off, a little bit of sanding, you can basically get rid of these. Now this is an example of the 0.8 millimeter nozzle on the CR10S PRO. There is a string all the way across. Again, you would have to get a heat gun and basically remove it. So let me show you some of the important parameters that you should be checking out. You may want to try these settings or test these settings yourself. However, I'm going to go through some of the settings that I have tried, some of the changes that I have used, and I'm not going to go into too much detail, but I want to show you that I have tried these settings, or tried to tweak these settings a little bit to see if they make a difference. And for the most part, these are not going to make any improvements or any difference to the print or the stringing. So there is an option here where it says where is it, right here, outer before inner walls. I tried changing the inner and outer walls. That doesn't make too much of a difference. Also, these wipe features, the outer wall wipe distance, the infill wipe distance, they don't make too much of a difference. The wipe nozzle between layers. Okay, let me just rephrase that. It doesn't make any significant difference in the actual getting rid of the stringing of the print. Another thing is that I have tried is coasting. Enable coasting right here. When you have the zits or the little blobs on the side where it has the seams, this actually helps a little bit if you change it. But let me just show you what it does. I'm just going to slice it as a regular without the coasting so you guys can see. And preview. Go here. Let's move the layer down. It does the regular inner wall and the outer wall. Travels inside, does a little bit of wipe, and then goes to the opposite side. By no means do you want to put in a high value right here. If you read right here, it says the value should generally be close to the nozzle diameter cubed. But I'm going to use a high number for exaggeration so you guys can see what it does. So it makes the regular extrusion, and where it makes the transition from the inner wall to the outer wall, you can see it does the regular travel move. However, it stops the extrusion process, and whatever's left in the nozzle or whatever's left oozing out of the nozzle is what's going to cover this surface area. And again, it does the outer wall, comes around, stops the extrusion process, continues on the path, and then it goes to the opposite side. I think you can quite possibly like double this, and it's not going to make too much of a difference because there's enough ooze that's inside the nozzle. However, if you make it too big, like I did, you're going to find holes in your model. See, there's a gap. Don't make this too big. And again, this is the speed of travel when it does the coasting. So from here, when the extrusion stops, this is where it slows down the coasting speed. This is a setting that won't affect the stringing too much. This is if you have a blob or the little zits that you see in your models. This is something that may or may not clear it up. The outer wipe distance, the infill wipe distance. When it comes to stringing, this will not help too much. Let me just show you what it does. Again, I'm just using these numbers to exaggerate what it does so you can see what happens. It makes the inner wall, and then it does the outer wall, and here is where the outer wall wipe distance is. It stops the extrusion of the extruder, and it still continues on the path of the outer wall to the 20 millimeter distance, or the distance that you put in here, before it moves to the other opposite side. This may actually help in the getting rid of some of the seams. However, if you do it where it has a small surface area like this, if it goes around this surface area too many times where the plastic is actually soft, you're going to find that there's going to be deformation, and this tip is actually going to tilt or topple because of the heat that's going around the plastic too many times. Again, if you have a small surface area, you don't want to really use this. If you do use it, just use like a 1 millimeter wipe, a small wipe, and use it in conjunction with the coasting. I think I covered most of what you may be looking into to get rid of the stringing, but this is actually the most important setting that you can use. The retraction. This will very well affect the stringing process. So retraction just means that the filament is retracted up back into the hot end before making that travel move. That does not mean that when the filament is retracted up into the hot end, the filament that oozed outside of the nozzle is retracted back up into the hot end. It just relieves the pressure inside the heating block, and that's all it does. There is no miracle where the filament that's already on the outside just goes back inside to the hot end. So any filament that's already outside has to be wiped in order to prevent the stringing. Now again, if it's a bigger nozzle with a bigger diameter hole, there's going to be a lot more filament, and you're going to need more of a surface area to wipe all that filament. Something you want to be careful about is this retraction distance. You don't want to make this too long. This is a part where the plastic has melted, and you can see there is a bulge because when the filament is pushed in, the diameter actually gets a little bit bigger before it goes into the nozzle. As you can see, there is a little bit of stringing, and if you have that distance of retraction going too far into the cold zone, there's a possibility that if there is some stringing, it could actually bend like this and cause more a clogging issue when it adds more diameter to the actual filament when it's cold inside the heating block or even the Bowden tube. Now, I'm not saying this is going to happen often. It's going to be like a rare case, but again, you don't want it to go all the way inside to your actual cool zone, especially if you have long stringing. This is for the CR10S PRO. I have it at 8 millimeter distance and 25, 25, 25. You can just take a look at my profile setting and the layer change, retract that layer change. It doesn't make too much of a difference at the layer change. It's not like you're doing a wipe before the layer change. So, and if you want to just take a look at the settings for my ENDER 3, I'll show you that right now. The only real difference to the settings for the ENDER 3 is that instead of the 8 millimeter retraction distance, I have it at 6. This Z-hop I was on the fence about. I would have thought that it would have made a difference, because when you do the Z-hop, the nozzle moves up, and when it moves up, I would have thought that it's not dragging on the surface area. When you don't use a Z-hop, the actual nozzle would drag on the surface of the top layer or top wall, and that dragging of the or wiping of the ooze be reduced by the actual dragging on the top layer or top surface. However, I didn't find that to be the case. It might be that this is only one layer of wall. If you quite possibly put two or more, or even more than that, if it's dragging on more of the surface during the wipe, it may remove some of that, more of that ooze. For a bigger type nozzle like a 0.8 millimeter, you're really not going to be putting too many walls because that will be a waste of filament. But again, that's something that you may want to try. You may want to put a little bit more walls, and when it makes that inner wipe, it may have more surface to drag on, quite possibly remove some of the ooze. But I find that the distance is so short that most likely it's not going to really get rid of all the ooze. Kind of like when you have a hot glue gun or whatnot, and then you start dragging it, it just gets thinner and longer. It doesn't really remove all that plastic, and that's basically what happens. So guys, there you have it. The most important setting that you can change to reduce your stringing issue is the retraction settings. I hope you guys found this video helpful. Go ahead and subscribe, like, share, comment. If you have any questions, definitely leave it in the comment below. Thanks.